Hi everybody, it's Holger Mueller from Constellation Research. Here I'm back with Dave Duggal, founder and CEO of EnterpriseWeb. This is our third session in a series of short interviews. In the first one, we talked about EnterpriseWeb's no-code integration automation platform. In the second one, we walked through a platform use case, a very interesting modernization to SAP's order fulfillment. Now, which I can't wait for, we're going to look under the hood of EnterpriseWeb. Hi Dave.
Hey, Holger, how are you doing?
I'm very good. I'm super excited about this. So let's have, really would love to hear what is happening when you have to deploy. That's how you start Enterprise Web. How does it work?
All right, fantastic. Well, let's just jump right into it then with the deployment details. So just to get this out of the way for technical folks on the line, Enterprise Web is cloud native. It deploys as a cluster of pods on Docker containers with Cassandra as a backing store. Uh, the platform runs on the JVM and can deploy anywhere on premise, cloud edge, or a laptop. And I think something that's compelling, since Enterprise Web itself is an integration and automation platform, Enterprise Web can naturally connect its own distributed instances in a mesh network, which we call an application fabric. So you can imagine Enterprise Web having sort of consistent deployments distributed that are all connected through events.
Very interesting. But one thing when you deploy stuff is what dependencies are in the fine print. Tell us more about that.
Sure. We keep it short and sweet because so all platforms have some level of stack based on some technologies, and we do too. So essentially, we bundle Graal VM for JavaScript processing. Tomcat is our Java servlet container, and Solr we use for indexing. So those are three open script engines that most people are very familiar with. They're very popular, widely adopted, and we use them as well, so we don't have to reinvent the wheels. But that's it. Everything else is enterprise web graph modeling and processing.
So, sounds pretty straightforward, right? The interesting thing is like, what does the graph play? What kind of role does it play in your no-code platform?
Yeah, I mean, graph is absolutely a differentiator for us. So I think the key here is to first consider graphs relative to the status quo, right? So traditional hierarchical modeling, which has been being done for the last 20, 30 years, essentially everything's into fixed static hierarchies, right? And those hierarchies sort of impose artificial constraints to essentially simplify, to put everything in these buckets. It imposes these constraints because you're simplifying your domain to fit the tool, right? The hierarchical modeling has some inherent constraints, and so your domain model is limited in what can be represented. So the models end up being tightly coupled. Everybody knows that these sort of big hairball, hierarchical models are expensive to maintain, and they're hard to change or extend. So in 2021, I think businesses are looking to graph data structures to support increasingly complex and rapidly evolving operations, right? Graph data structures are different because they make relationships first-class citizens. So they can more flexibly model the real world. Based on conditional relationships, one-to-many relationships, and even changing relationships.
Totally agree on that, right? I mean, graphs have really changed the way how we can model the real world, and that's super cool about them. But nothing explains better than an example. Can you give us a good example of what graphs can do that people can relate to?
Yeah, I mean, the web is a graph that everybody uses every day, but probably the best graph that people recognize the most is the social graph, right? Everyone sort of intuitively understands that they have a network of relationships, right? That network is a graph, right? They add relationships with new friends, family members, and business contacts. And every once in a while, they lose a relationship or they defriend somebody or something like that, right? Um, we have visibility not only to our friends, but our friends of friends, and we can see second and third degree relationships. You can essentially navigate that. That network is transparent. And there's also a sense that our networks are part of a bigger graph. And that's a really interesting way to model things. So graphs are inherently transparent, but they're also extensible and adaptable, right? They have properties that we don't see in our hierarchical modeling.
Which is super important that they're extensible and adaptable, right? And the social graph is a great example, but let's give us an example in the business context, Dave.
Yeah, I mean, if you think of the social graph, I mean, a business can be described similarly, right? I mean, what is a business? I mean, a business is a set of people, information, capabilities that can get connected by events and policies, and that's truly agile, right? If you actually think in that mental model, right, it's just I'm an entity. I got people, information capabilities of various sorts and types and distributed different places. That's fine, but that's okay. They're all just endpoints being connected by events and policies. And that really is an agile way to think about the universe. So, going down a level, you can actually easily see that cloud native applications are also naturally modeled as graphs, right? I mean, today's distributed application is not a monolith, right? Nobody wants a monolith. A distributed cloud native application is a composition, really, right? It's a set of service endpoints with relationships connected by events and policies. That's really their true nature, right? It's when we tightly couple them with static models, custom code, manual integration, that's actually what becomes our problem. It obscures this truth, right, of their graph nature, and sort of inhibits the agility we want.
That's very cool. So now we know how to install it. We know the dependency. We understand the fundamental elements of that, and how important graphs are, of course, for a no-code platform. How did people get started, Dave?
Yeah, I think we ended our last call talking about making it easy for developers, right? And that really is the key to leverage the platform, right? Because if we made it, if it was too hard, then developers would be turned off and they just do what they do best, right? They would do what they know. So I think the key here is to make this the platform a practical IT productivity solution that empowers developers. So it has to be easy for them to use. So as we described on those in the use case call, and even I think in the first call, we really have three basic steps, right? We make it easy for architects to model their domains, and they can jumpstart that domain modeling effort with existing models that they have. They can import RDF files, JSON files, XML, whatever. Then IT can rapidly onboard their service elements, mapping them to that domain. They essentially become domain objects. A wizard. One thing we haven't really discussed is that onboarding process is sort of driven by a wizard. It itself is a model-driven process in Enterprise Web that guides the IT person to onboarding that object. So it allows them to upload files and artifacts, and the wizard will autofill properties and generate interfaces. And essentially, we're creating a digital twin, right? This is going to be a really rich object that we're going to create quite quickly that's mapping properties, behaviors, constraints, and dependencies. Essentially, it's creating this like replica of this either physical or logical object so that we can control it virtually, right? And once those are registered in the catalog, service designers can literally just go point and click at the objects in the catalog, declaratively compose them into services, and chain them into event-driven processes with no code, right? It's all being done through the graph, all through metadata.
Very interesting. So that sounds all very logical, very rational, very intuitive. Everybody should do that. Why are there not dime to a dozen providers of this? Why hasn't this done before? What's your take on that?
Yeah. I mean, absolutely. I think there's one basic reason is, we're talking about these distributed applications and distributed domains as being inherently complex. And I think that the problem is making things that are complex simple is actually hard, right?
Right.
I mean, the iPhone is a great example, right? The iPhone is just this magical black box that we all use, but it's obviously a very complex piece of engineering. Enterprise Web, likewise, is trying to make things easy for everyone, but that's been hard for us. But I think also then in computer science itself or in engineering, to date, graphs have been primarily used for analytics and recommendations, not for business processes and transactions. And there's a specific reason for that. It's because all these graph dependencies that we're making easy in Enterprise Web have traditionally been considered expensive to process, right? It's a lot of processing, right? All these things that we're doing in a loosely coupled way with all these metadata references, all that has to be interpreted by the system's runtime. And that's a lot of processing that we're now putting into the event, right? Into the real-time moment to have a contextualized service. And that has been historically expensive. So Enterprise Web is making this graph processing practical, scalable, and performant for real-time, data-driven applications. I mean, we actually have 15 awarded patents on this topic.
That's interesting. Intellectual property IP is super important in this, right? No question. But that's a great segue. Give me an idea how you process these graphs, right? Describe how the enterprise runtime handles them, because it's performance critical, as you mentioned.
Yeah, absolutely. So, for performance, scalability, portability, Enterprise Web itself is cloud native, right? It's event driven, it's asynchronous, it's concurrent, it's all those sort of basic app properties that everybody wants to hear about a platform today. As a business process and transaction enabling system, it includes reliable messaging, so immutability and idempotence are taken care of. I know these are technical terms, but technical people will appreciate that because those are hard to engineer into solutions. And as well as transactional guarantees, retries, circuit breakers, traces, compensations, rollbacks. Those are all enabled by the system, so engineers don't have to program them again and again, one off into every application. The platform itself, you can almost think of it as a single API over your domain, and the platform is acting as a service factory. So every request for objects in the system essentially is a listener for those events and requests, and we're going to process those events as a saga pattern. That's a well-known pattern in the event-driven world. And transaction state, because as I said, we're stateless, we're cloud native. We're persisting transaction state in durable entities, right? So we're taking a cloud native approach to managing state. We're decoupling the processing from the state. The state is persisted into these durable entities. And then the event processing itself is performed by generic agents, right? So agents run, essentially agents are functions as a service. So these stateless short-lived processors running on logical containers, and they execute in parallel. You can imagine all these agents coming out, self-organizing themselves to execute every request. And because they can execute in parallel, they're taking big problems and they're addressing them very efficiently.
That's very, very interesting, right? But obviously we're peeling the onion here, right? Getting there. So the workload processing is super critical for the whole system. Can you give us a little more detail about how that works?
Yeah, I mean, the best place to start is to consider big data, right? Everyone familiar with big data understands that large jobs could be distributed into, amongst a lot of nodes, all doing the same processing, right? So that you can take one big job, distribute it to 1,000, 10,000, whatever it is, and then aggregate that back up, and you have your payload. EnterpriseWeb is doing something similar, right? Except that we're taking these complex graphs and we're decomposing them, right, into lots of diverse tasks, right? So it's not one workload, common tasks, a lot of agents doing the same thing. This is actually, EnterpriseWeb is actually looking at all the tasks required to fulfill this request or event, distributing that out to agents that are working independently. They're all writing back as they complete their discrete tasks. They're writing back to that transaction object, to that durable entity. And as they write back to that durable entity, that might be triggering more agents to continue the processing, to advance the processing of that event. And that continues so on until complete. So what's interesting here is these agents are actually, essentially being dynamically configured to handle whatever they need to do, right? These diverse workloads, right? So that could be integration, transformation tasks. It could be orchestration tasks, service orchestration, data orchestration, device orchestration. It could be configurations of apps, networks, and devices. It could even be business process automation. Now, normally you would think about that being represented by many components, maybe a half a dozen, or more components or cloud native tools that all have to be manually integrated. Instead of that, EnterpriseWeb is stripping away all that cruft, right? That also helps us, right? We're getting rid of all these components, right? That added complexity, that added overhead, and we're just actually doing it all with serverless functions that are dynamically configured on the fly to perform these discrete tasks.
That's just very, very impressive, very interesting. I'm really happy to have done this deep dive with you, Dave, and to understand better what's going on in behind the scenes in the EnterpriseWeb platform. Great to learn more about the capabilities and technology. Thank you so much.
Well, see, I told you it wasn't magic.
No, it's not magic. Hard work. And how many 15 patents, right? Thank you.
Hard work. Lots
Thanks
of
for sharing it with us. Thanks, Dave.
Great. Thank you so much. Bye-bye.